Welcome to Understand the Math. In this video, I'm going to walk you through how to graph transformations of functions in a way that's easy and makes sense. We'll start by going over a summary of each different type of transformation, and then we'll walk through two examples together using 4 easy-to-follow steps. Let's start by going over 3 different ways that a function can be transformed. I have a video on these transformations if you need a little bit more of an in-depth review of them. When you graph a function that has a transformation in it, you're going to start by graphing the parent function. I've listed a few of these parent functions here, and you're probably already familiar with many of them. After you graph the parent function, you'll scale the graph. You'll stretch or compress the graph vertically, or you'll stretch or compress the graph horizontally. After that, you'll translate the graph. When you translate the graph, all you're going to do is either move it up or down, or move it to the right or to the left. After that, for some functions, you may need to reflect the graph. You'll need to reflect the graph if there's a negative sign with the function, and in that case, you'll reflect it about the horizontal axis. Or if there's a negative sign with the x, you reflect the graph about the vertical axis. Now that we know what to do, let's go over the first example. In this example, we're going to graph the function f of x is equal to 3 minus 2 times the quantity x plus 1 squared. On the right, I've listed the steps that we just went over, and we can use these as a guide. The first thing that we want to do is graph the parent function. When you look for the parent function, you want to just ignore all of the constants and just focus on x. So when we look at our graph f of x, we can see that our parent function is f of x is equal to just x squared. And that's what we're going to graph. The function x squared is a parabola. It opens upward. It passes through the point 1, 1 and minus 1, 1. And then when x is 2, our f of x is equal to 4. I'm just going to put these points on here so we can use it as our guide. Now we're going to go ahead and we're going to graph the function. And it's going to go through all of these points. Okay, that's the parent function. Now the next step that we're going to do is we're going to scale the graph. When we scale the graph, what we're going to do is we're going to look at the constant multiplying our function, and that constant is 2. We're not going to worry about the minus sign right now. We'll worry about that later. So let's just write down that we're going to graph now f of x is equal to 2x squared. When we have a 2 multiplying our function, that means that our function is going to be stretched vertically by a factor of 2. Let's go ahead and write that down. We have a vertical stretch by a factor of 2. Let's see how to graph this. Our original function x squared went through the point 1, 1. Now we're going to stretch that vertically. So our point now is going to go through 1, 2. We just multiply the 1 times 2. And we can go ahead and do that on the other side as well. And then we can go ahead and graph our function. So you can see that it's stretched vertically by a factor of 2. Now let's go to our third step. Our third step says that we're going to translate the graph. So to translate the graph, we are going to look at these numbers up here. We're going to look at the plus 1 and the 3. So I'll write down f of x is equal to 3 plus 2 x plus 1 quantity squared. This 3 indicates that our function is going to move up by 3 units. And the x plus 1 tells us that our function is going to move to the left by 1 unit. What we're going to do is we're going to look at the vertex to look at this translation. So our vertex was at 0, 0. Now our vertex, we're going to move it up 3 and 1 to the left So our vertex is going to be right there. I think it's going to help us graph our function if we put a new horizontal and vertical axis connected to that vertex. Let's go ahead and draw that. We're going to draw a dotted line here and then a dotted line here. And that's going to really help us graph our function. To graph our function, we're going to go 1 point over to the right and up 2, just like we did with this point. And that goes through here and then here. And then we can go ahead and we can graph our function. Now we only have one step left, and that step is to determine if we need to reflect the graph. Notice in our function that we have a minus sign right there. That tells us that we need to reflect our graph. So all we're going to do is we're just going to take our purple graph and we're going to reflect it about the horizontal axis. So in our step 4, we're going to graph the entire function. F of x is equal to 3 minus 2, x plus 1 quantity squared, and we are going to reflect it about the horizontal axis. So let's go ahead and do that. Now we're going to go to the right one and down 2. So let's go ahead and put a point here and here. We're just reversing the direction. And then we can go ahead and graph our function. I'm going to go ahead and highlight it so that you can see that this is the graph of our function. Let's look at another example. In this example, we are going to be graphing a function that has a square root. Just like we did for the first example, we're going to start by graphing the parent function. So let's write down what the parent function is. Our parent function is f of x is just equal to the square root of x. Let's remind ourselves that this function is not defined for all x. It's only defined for x greater than or equal to 0. Let's now plot f of x. Notice when x is equal to 1, our f of x is 1. And then when x is equal to 4, our f of x is going to equal 2. Let's go ahead and we'll plot 0, 0, and then we'll plot the 1, 1. And then when x is 4, our function is going to be equal to 2. Now we can go ahead and graph f of x. Let's now go to our second step. Our second step says that we are going to scale our graph. The function that we'll graph in our second step is going to be f of x is equal to the square root of 1/2 times x. Notice that x is being divided by a factor of 2. That means that we're going to have a horizontal stretch by a factor of 2. Let's look back up in our graph and see what that means. If we look at this point right here, that's our point 1, 1. We're going to now stretch that point horizontally by a factor of 2. So it's going to be this point right here. So instead of going through 1, 1, it's going to go through 2, 1. And our vertex stays the same. And now we can go ahead and graph our function. So it just stretches now horizontally. Let's now look at our third step. Our third step is where we're going to translate the graph. So when we look back up at our function, we're going to pay attention to the x minus 3 and then the 1. Let's go ahead and write that down. So our function now is f of x is equal to 1 plus the square root of 1/2 x minus 3. The 1 says that we're going to move our graph up 1. And then the x minus 3 says that we're going to move our graph to the right by 3. So we'll write down right 3. Just as we did in our first example, when we translate a graph, it's helpful to go ahead and draw our new horizontal and vertical axis. Our axis is going to go up 1 and right 3. So this point is going to be our new vertex. And we can go ahead and draw our dotted lines. And they look like that. Now let's go ahead and let's graph our function. Notice with our pink function, we went over 2 and up 1, so we're going to do the same thing with our purple function. We're going to go over 2 and up 1, and that's the point that we're going to go through. So we can go ahead now and graph our function. Before we talk about step 4, I want to talk about the domain of this function. Notice from this part of our function that our function is only going to be defined for x minus 3 greater than or equal to 0, because you can't have a negative square root. So that means our function is going to be defined for x is greater than or equal to 3, and that's exactly what we drew on our graph. Now let's talk about step 4. In step 4, it says to reflect the graph. We only need to do step 4 if there is a negative sign in front of the parent function. Notice with this parent function, the square root of x, we have a positive sign. So because of this, we don't need to reflect our graph. And the graph that we drew in step 3, that I'm going to highlight here in green, that is going to be the graph of the function. Now you know how to graph transformations using parent functions. Remember, start with the parent function, then scale the graph, translate it, and then reflect it if the parent function, or x, has a negative sign.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.